This video is over section 3.6. 3.6 covers compound inequalities. All right, and compound inequalities are and problems or problems. Compound inequalities are pretty straightforward, pretty simple to use, to do. Just got to pay attention to what's going on. All right, now compounds is exactly what it sounds. They look more complicated than the ones we looked at in a previous lesson. All right, so number one's compound. It's more complicated because it has two inequality symbols in there. It's got that and it's got this. Okay, so it's got the two less than symbols in there. All right, now notice how your variable's in the middle. So you have two symbols in the same problem, and your variable, your x, is in the middle of those two symbols. We call these compound and. So they're and inequalities. All right. And then likewise, down here at the bottom in example 3, okay, see how it says the word or in the middle? And they're actually two separate problems, all right? So 9 plus x is less than or equal to 7, or 3x is greater than or equal to 12. So we call these compound, all right, and or. And the reason I'm just putting the or in quotations and the and in quotations is usually we just refer to them as an and problem or as an or problem. Okay. When you deal with an and problem, the way you solve it is you, excuse me, is you want to get the variable by itself in the middle. So you have x minus 3 in the middle of those two inequalities. Well, if you want the x by itself in the middle, the 3 has to move. So we put a plus 3 because it's not attached. So we move it just like we do anything else. Now here's the only trick here. When we do it in the middle, when we put plus 3 in the middle, we have to do it on all three sides. So it's almost like having a three-sided equation, if you will. And then negative 2 plus 3 is 1. Less than symbol. Those canceled, so I have x. All right, 7 plus 3 is 10. So here's my answer. All right, now this is actually really easy to do if you think about it. So here's your answer if you're going to draw the graph. Literally, x is in the middle of 1 and 10. So that's how you show this. Just put your low number on one side, your high number on the other. The first inequality symbol here, that goes with the 1, so it's going to be an open dot. This one goes with the 10, so it's also going to be an open dot. And seriously, shade in the middle because x is in the middle of those two, is just the way that your answer is written. All right. Another one that's a little more complicated just because there's more to do. It's the same idea. A couple of things we need to watch out for, though, and be careful with. All right, so I'm going to move the 9 first. I have negative 2 over here then, less than or equal to negative 2x, less than or equal to 6. I'm going to divide by negative 2. Now, same rules apply. Look, I'm dividing everything by a negative. So same rules apply as the normal inequalities. I have to flip the way the symbols face now. All right. And now the trick on this is this answer is okay. We normally don't like to write it like that. We normally like to put the small number first. So the smaller number out of 1 and negative 3 is negative 3. And we change well, we're not really changing the signs because if you look at this, see how the arrow's pointing at the negative 3? So when I rewrite it, the arrow's still pointing at the negative 3. And then this time I want the arrow pointing at the x for that one. So it points at the x, and then we have our 1 here. Okay, so there's your answer. And the reason why I like rewriting it like that is because you have to put your numbers in the correct order. The smaller number is always first. So if you looked at it this way, all right, a lot of people tend to put the 1 first on the number line and then the negative 3. You can't do that. The smaller number's got to be to the left. Okay, so here we are. Let me just shade in between them because it's an and problem. So pretty easy to do, especially after you've seen your teacher do a few examples. The video makes a whole lot more sense. All right, when you do ors again are really simple. You just do it as two separate problems. All right, so I'm going to subtract 9 from each side. I have x is less than or equal to 7 minus 9 is negative 2. This one's done. Now I just do the other problem. The other part of this is a completely separate problem. Just do it as two separate. So I'm going to divide by 3. Okay, so nothing more to do, so here's my answer from that one, and I just put the word or between them. There's my answer. And when I graph ors, just graph it as two separate problems, all right, and then just however it works out. It works out how it does. So always put the smaller number first. You got to be careful. because sometimes the smaller number is not always the first answer. So I have -2 and 4. I'm going to put the -2 first. I'm going to put the 4 second. Okay, and the only reason I'm doing these in different colors is so they match up with my answers that I have here. So it says x is less than or equal to -2. So -2 gets an open dot on it, or solid dot on it, excuse me. Less than or equal to. Less than goes this way. Okay, greater than or equal to 4. And we don't need to worry about shading in the middle. We don't need to worry about any of that stuff. That's your answer. Just wherever it happens, wherever it works out. Okay, so easy enough. All right, now working backwards, going from a graph. This should be pretty straightforward for you as well. All right, if you have the middle shaded, it's and. If you have like the two different shadings, one in either direction, that's going to be an or problem. And if you just have like a normal one dot, one shading, that's going to be just a simple normal inequality, and that's what we did in the last unit. So if I look, I'm shaded in between two numbers here in number 1. Well, if I'm shaded in between, it's and. So the way I do this is I always put the small number first, the larger number second, and I put my variable right in the middle. So x is between -4 and -1, and then the way I show in between is with two less than signs. All right, now they're both going to get bars underneath them, because they both have solid dots on them. The -4's got a solid dot on it, so it gets a equal to bar. And the -1 also gets an equal to bar because it's got a solid dot on it as well. All right. If I look at number 2, here's the difference. Again, I'm shaded in between this and this. All right, that's where my shading is. So it's the same thing. Okay, 3, x in the middle, 7 on the right, and then same type of deal here. All right. They both get less than signs. The 3 is the only one that gets the equal to bar underneath it because it's the only one that has a solid dot on it. All right. Now, when I go into number 3, if you look at 3, I have two separate shadings going on. I have two separate dots there. So I'm going to write an inequality for each one of them. So for the first one here, I'll just do these in two different colors so it's easy to see. For that one, it's x is less than 0. All right. This is how I know it's or, is because I have the two tails of the graph shaded in. And then this piece right here is x is greater than or equal to 6. All right, that's my answer for that one. Again, pretty easy, pretty straightforward. Okay, just a couple of word problems out of these. Looking at number 1, notice this car can travel between 380 and 410 miles on a full tank of gas. All right, whenever they say between, they're telling you it's an and problem. She filled her gas tank and drove 45 miles. How many more miles can she drive without running out of gas? All right. Well, think about this. Her car goes between 380 and 410 miles an hour, or 410 miles on a full tank of gas. So she's going to get somewhere if her gas goes in between these on a full tank of gas. Okay, so mileage is somewhere in between there. And she's already drove, all right, 45 miles. But she's already drove this much. There's your inequality. So now we figure out, all right, what happens. How much further can she go? All we do is we solve it. Just subtract 45 from each. So pretty straightforward in how this stuff works.